Okay, couple things before I forget. Hey, everyone, saw a few of you your papers when you handed them in. I noticed when you draw your vector, it's got to stop at the point. Okay, it just starts at C, goes to D. I just noticed some of you had the points there, but you just went like that. So it's not going to be wrong, but just remember the vector starts and stops. So today we're doing vectors again, but instead of saying finding the magnitude, it's going to say find the speed. Speed and magnitude is the same thing. Okay, and it's the same thing as finding the distance of a vector. So to find this vector right here, first of all, if we had to write the component form of it, CD vector CD is over 1, 2, 3, 4, 5 and up 4. So to find the speed, it's just finding the distance of it, which, remember, these just give you the length of the legs of the right triangle. So the speed is just 5 squared plus 4 squared square rooted. It's just the Pythagorean theorem. You guys see the connection between this and the right triangle? And all of these will just round to the nearest tenth. But I messed up already. These go by fives. So this is 25 and that's 20. So it's 25, 20. So we got to go 25 squared plus 20 squared and then square root it. 32.01, so it's 32 and it's in miles per hour. Okay, so I showed you then that yesterday. It's the same thing we've done, but now what's new is we're doing the direction. The direction is two things. It's the angle and direction. When we think of direction, we think north, east, south, west. But in these vectors, you also got to have the angle that it goes with the horizon. This is the thing a lot of people forget to do. So it's always formed with the horizon. So it's going out and up. So we got to find that angle right there. Angle C. So we got to use our, no, to find the angle, we got to use the trig ratios. So if you look at the angle and you look at these two that we know, which is tangent. On these vectors, it's always going to be tangent. That's what's kind of nice about that, because you're always going to know the two legs. So to find this, we'd say the tangent of C equals the opposite, 20, over the adjacent, 25. Now, everyone remember what to do when you're looking for an angle?
Yeah, you just cosine, cotangent.
C equals the tangent inverse of 20 25ths. You got to use the inverse key. That's the one that's right above the tangent. So, like on these calculators, you got to divide this first. You got to go 20 divided by 25, press equals, and then hit the tangent inverse key.
38.7.
38.7, yep. So this would be 38.7 degrees. Up is north, to the right is east.
So they're all going to be tangent?
Yep, on a vector they always will. Okay, so here's your directions in case you're not sure about them. Okay, so here we've got a vector. This is an air balloon. Again, these go by fives. I think the ones today go by tens. I'll point them out before you do them. But the air balloon is going from here to there. So when we make our right triangle, you've got that.
Do you have tissues? Say no.
No.
Who does? Who does like tops? We're all gonna die. My case broke.
Yeah.
I'm gonna go, like, yeah, two.
So, writing the component form of this, which we don't have to do today on the problems, but just so we get used to doing them, because you will on the test. Vector JK goes left 5 and down 25. Okay? So, to find the speed, we've got to find the length of the hypotenuse. So you just use the Pythagorean theorem. A squared plus B squared. Shh. Quiet. So remember, even though that's going left, it's negative, and down is negative, distance is never negative. So it's just 5 squared plus 25 squared, square rooted. 25.5. So it's 25.5 miles per hour. And then to find the direction, we got to find the angle formed with the horizon, which is angle J. So opposite of J is 25, adjacent is 5. So the tangent of J is 25 over 5. So you move that over. J is the tangent inverse of 25 fifths.
78.7.
78.7 degrees, and that's going down, which is south, to the left, which is west. So there's the speed, there's the direction. When we do these on the test in a couple days, you've got to do this, the speed and the direction. Okay? So, everyone got these done? No?
Yeah.
Okay, this is no big deal, equal and parallel vectors. You guys know what parallel means, right? Equal, they're the same. This one and this one are the same because they're both the same distance and they're both going up the same length. Alright, but the adding vectors, sum of vectors, I showed you this before. Here, vector u is 6, negative 2, and they got it drawn here. Here's where they started. So, for u, it's positive 6 down 2, so it goes from here to here. And then v goes left 8 and up 7. It's like an airplane flying from this airport to this airport, and then they're coming here. They go left 8 and up 7, so they fly from here to here. If you add these two vectors together, all you got to do is add the x's. 6 plus negative 8 is negative 2. And then negative 2 plus y, or 7.
Is 5.
So that's how you add vectors together. Which, if you look, if they would have just flown right from here to where they ended up, it's left 2 and up 5. Okay? So, when it's like this, to find the sum of vectors, you just add the x's, add the y's. There's some of these on the test, and believe it or not, every year some people get these wrong. Add the x's,
Nobody will get them wrong this
add the
year.
y's. I hope not.
No, you won't. I won't say that.
Okay?
No, you won't say that.
Now, just to show you again how the vectors work,
Jason, shut up.
Let's say it.
okay? If we had these vectors, u is 3, negative 5, which means we'll just start somewhere. 3 is positive, so I go right 3, down 5. So if I connected those two, this is vector u. Then, so you think of the airplane flying from this airport to this airport. And then they're flying to another airport, which is 2, 7. So it's right 2, up 7. So then it flies from here to here. So when they add vectors together, we can just look here, 3 plus 2 is 5, negative 5 plus 7 is 2. It's the same thing as if they would have started here and skipped this and flown right to there. Over 5 up 2. Okay? So when you add two vectors together, what it's saying is you're just skipping, you're going from the beginning to where you straight to where you end, instead of doing the other trip.
Alright.
Okay?